Okay, so this problem involves a convex lens that is needed to produce an image that is 0.8 times the size of the object. So we have a convex lens, and we know that if the image is 0.8 times the size of the object, that means the magnification is going to be 0.8. But we don't know the sign yet. Let's continue, and it says the image is going to be located 24 centimeters behind the lens. So the image, so if this is the lens, here is my object, and so my image is going to be here 24 centimeters behind the lens. Now if that's the case, we should realize that in fact there's no way that, though I've drawn it too big here, so that's not quite right. Let me see if I can do that again. I'm going to make it a little bit smaller because it's supposed to be 0.8, but this distance is interesting because this distance, the fact that it's on the opposite side of the lens, that's what tells me that it's going to be upside down. There's no way that the image could be right side up on the opposite side of a convex lens. Therefore, I know that this has to be negative. So, when we continue, it says, what focal length should be specified? So we'll say f equals question mark. Now this is the image location, so I also know that the image distance is 24, and that's going to be a positive 24. So therefore, if I calculate, I'm going to say if I do, I die. Now in order to calculate the focal length, I'm going to need the object distance and the image distance. I already have the image distance, but I don't have the object distance. Fortunately, I do have the magnification. And so therefore, I know that that's equal to negative dido. And therefore, if I was to calculate the object distance in this case, using this equation here, I can simply swap the negative 0.8 and the object distance and get negative di over negative 0.8. And so that's going to give me negative 24 divided by negative 0.8, and that 24 enter 0.8 divided by, that's going to give me precisely 30. And so now I can calculate my focal length simply by going 1 over do plus 1 over di, all reciprocated, and if I plug my values in, I get 1 over 30 plus 1 over 24, all reciprocated, and I get my focal length to be 24 reciprocated plus reciprocated 13.3, and that is my focal length. That's a 1. So that's the question. Hope you enjoyed it.